Good morning, everyone. Well, it's morning for me. Hopefully it's not morning for you, because that means that maybe you got to sleep in today. I don't know. Anyway, today we're going to do chapter 7.4, Finding Sums of Infinite Geometric Series. So let me read that again. Finding sums of infinite geometric series. Now I know what you're thinking. You're like, Mrs. Oldham, how can you find a sum of something that goes on forever and ever and ever and ever and ever? I mean, you're just adding things onto it, so how can you get a sum? That is a very good question, and that's one of the things we're going to talk about today. All right, so first of all, just a little bit of vocabulary here. The sum of the first n terms of an infinite series is called a partial sum, okay? So basically what this is you're taking a finite part. So that's pretty easy to get, okay? The sums of an infinite geometric series may approach a limiting value. Okay, so that is something that we're going to see today. It's basically like an asymptote. You get closer and closer and closer. You never quite get there. But the asymptote is that line. You're going to notice that the sum is going to be like the asymptote. Okay, so, but coming back up to here, okay, we know that in a finite series, we have so many that we're adding up. Even if it's a million things, it still ends, okay? So that is what is called a partial sum of an infinite series. It's a finite part of that. Okay, so let's consider this. This infinite geometric series. And it says to find and graph the partial sums for 1, 2, 3, 4, and 5, and then describe what happens as S sub n to S sub n as n increases. Okay, so we're just going to look at this. This is our series, and it goes on forever and ever. All right, but what is S sub 1? That's my first one, right? This is first one, second one, third one, fourth one, fifth one. And it's 1/2, which we can also say is 0.5. Okay, S sub 2 is adding these two together. So I have 1/2 plus 1/4, which is 0.5 plus 0.75, I'm sorry, 0.25, I'm getting ahead of myself, equals 0.75. Now instead of sitting here doing all this, this is what we've got when we add them all together, okay? So we have 1/2, we have 0.75. When we add these three together, we get 0.88. When we add those four together, we get 0.94. Add another one, we have 0.97. So let's look at this and let's graph it. So when n is 1, we have S sub 1. And I'm going to do 1, 2, 3, I'm going to make 1 right here, 2 right here, okay? So the first one is 1/2. This is 1/2. Okay, S sub 2, which is right here, is 3/4. S sub 3, 0.88, is going to be about right there. The next one's 0.9497. Blah, 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 blah. Goes on forever. But what do we notice about this? Hopefully you see the asymptote. The asymptote is at 1. So we can see that this is hugging 1. And is it ever going to get there? It's not actually. It's going to get closer and closer and closer and closer, but it's never going to get there. Okay, so remember this formula from last section, the last section, 7.3. Okay, this gives us our sum. And so let's look at this, and we're looking at this, we don't have an n. N is infinity, right? But let's plug in what we do have for that last one. We know that a sub 1 was 1/2, that was our first one. And we know that the rate, remember it was 1/2 plus 1/4 plus 1/8, right? Yep. So our rate, it's being multiplied by 1/2 every time. Okay, so if we plug that into the formula, we have S sub n equals a sub 1, which is 1/2, times 1 minus 1/2 to the n power over 1 minus 1/2. So all I did was plug things in. My rate is 1/2, my a sub 1 happens to be 1/2 also. Okay, so let's see what we've got here. 1/2 times 1 minus 1/2 to the n power, and this is 1 minus 1/2 is 1/2. Well, the 1/2s cancel, right? We've got basically 1/2 divided by 1/2. So S sub n equals 1 minus 1/2 to the n power. All right, well, what happens to 1/2 when n gets really, really big? What is 1/2 to the, let me grab my calculator. What is 1/2 to the 10,000th power? Let's see if the calculator will even do that. 0.5 to the 10,000th power. Oh, it says 0. So basically the number is so tiny that it's basically 0, okay? So what happens then is this goes away, and S sub n is 1. I have another slide that looks exactly the same, and we're going to talk about this in the next video. I know how excited you are, yay!